thank you very much for joining me on this session. We'll be talking about security and how to secure your software development lifecycle. I'm Abubakar Siddiq Ango. I'm a developer evangelism program manager at GitLab and also a Google developer expert for cloud and a CNCF ambassador. If you want to talk about supply chain, software supply chain security, DevSecOps, infrastructure, I'm always game. You can reach out to me on Twitter or LinkedIn. I'll be sharing more of those details later. Now, in a recent survey we did at GitLab where I work, 57% of respondents, about 2,000 of them, responded that their organizations, they are confident in the way their organizations are now taking security more seriously. Now, in the industry, a lot of folks are now talking about shifting left. You know, when you are building your software, in your software development lifecycle, you move from left to right. You start with your idea, you write your code, you build your applications, you deploy them, moving from left to right. But a lot of organizations tend not to prioritize security until the end of development lifecycle. So shifting left means taking security right from the beginning of the development lifecycle. And it's a good thing that 57% of respondents said their organizations are not taking it serious. That means they are prioritizing security. Now, but the issue is 43% of security professionals that responded mentioned that they still don't feel confident in their organizations being prepared for things that can happen in the future. And rightfully so, recently, according to a survey by Sonatype, there has been an increase in supply chain security. Most times when we talk about security, a lot of people think about, oh, their account being hacked, their Facebook account hacked, their password being leaked, and so on. But a lot of bad guys have started discovering that, oh, you can secure your account. A lot of companies now have what we call airtight security systems around their network. Even if you use your computer as a developer or as a staff of a company on a network that they don't recognize, they might lock you out. But a lot of companies fail when it comes to their software. Now, there was a recent incident that happened, I think last 2 years, Log4j. The bad actors, hackers, discovered that in the way we log, most applications send logs using Log4j is an application by a company. There was a way they can pass some code to be executed on the servers, and that way compromise security of some systems. There was another incident that happened, SolarWinds. I can actually show you a timeline of a couple of them. There's a company called SolarWinds. A lot of government institutions and corporations use them for their IT systems. So instead of attacking those companies, why not attack their supplier? So by the time they trust their supplier, so when you attack, you compromise their supplier, you can easily get to them. And it affected a lot of companies, especially US government organizations. So it's why a lot of people are now saying we really need to take supply chain security seriously. Now, there was an incident. How many of us are front-end developers here? Front-end, you use NPM install, NPM update, etc. In 2016, there was an incident that happened. A developer has a lot of packages on NPM. One of them was called Kik, K-I-K. But that is the same name as a messaging app. It's not popular here, but it's popular in Europe. Kik messaging app. They now reached out to NPM that someone is infringing on our brand. Please ask them to take the package off. So NPM now went to the developer that this is the concern and so on. So out of protest, he took off all the packages he published, including LeftPad. And LeftPad is a package that a lot of millions of people use. So on taking it off, he broke a lot of people's pipelines. Because people would just say, NPM, add this package. They enter their package.json file, just add package. During build, it pulls that package. You now discover, your builds are now failing. Your CI are now failing. What is happening? There was a time Docker introduced rate limiting. If you want to pull Docker packages from the same IP, after some time, they will block you. So if your CI depends on Docker and you've reached that rate limit, especially like in Nigeria here where service providers use the same IP address for millions of people, you will not be able to pull any Docker packages any longer. So it's one of the, it's not just bad actors, but once you have actions or situations that block your productivity, block your developers' productivity, it becomes a supply chain issue. We all remember the Suez Canal problem, when a ship took the wrong turn and blocked the Suez Canal. It shook the whole supply chain industry of the world. The same thing with software. Now, let's look at places where you might be vulnerable in your software development lifecycle. Most of us developers just think, you write your code, you just push the Git. The remaining thing are the engineering manager and DevOps wahala. But the issue starts right from your system when you write your code. Are we sure the code you are writing is secure? Are we sure you are using the right dependencies? Are we sure your systems are secure? When you are now pushing your code, where you are storing your code, are you sure it is secure? Are you sure the self-hosted Git server that you have in your company is secure? When you want to build your application, something happened to Dropbox very recently. A hacker went and created a phishing attack for Circle CI. Circle CI is a popular CI platform. Dropbox engineers use it. So when the engineers saw the Circle CI interface, they logged in. They entered their OTP, not knowing it's a phishing website, not the real Circle CI page. And that was how a lot of internal project of Dropbox was compromised. Now, when your source, stage C, when your source is being built, are you sure the CI platform is secure? Are you sure it's not being compromised? When you build your packages, when it's building, like the thing I mentioned about NPM packages, how are you sure the Docker package you are using is secure? If you are using Terraform to build your infrastructure, how are you sure what you just pulled from the registry is secure? How are you sure your NPM package is secure? Your dependencies, how can you be sure of them? If you work in regulated environment like fintech, where they have a lot of regulations, does the package you are using meet the regulations of your organization, or it will compromise your organization? Down to your applications running in production. Or at all these levels, things can go wrong. That is why in the industry, a lot of ways has been brought up to be able to mitigate some of these issues. For example, while you are writing your code, if you are writing, let's say, for example, Terraform, infrastructure as code, we now have what we call IAC scanners. They will scan your Terraform files to make sure that the packages or the providers of Terraform you are using meets the regulation or the framework that your organizations are adopting. We have things like license scanning. A lot of organizations, especially in regulated environments, they will tell you, don't use this license, don't use that license. Even some companies will say, open source Gabart don't use for security reasons. Your software development lifecycle, your CI, continuous distribution pipeline, should be able to detect that, this license that I'm using, how am I sure that it's secure? How am I sure that it meets regulations of our industry? We have, for example, when you are building your container images, container scanning, there is a lot of vulnerabilities out there. If you use a tool like Trivy, Trivy, you can be able to scan container image to know which one is compromised. Sometimes it might be that it's not your fault, but there's a CVE. A CVE is a bug that has been discovered and published to the world so that everyone will be aware. It might be that the container image, you as a developer, you just found an image on Docker registry. You want to build your packages, and you just pulled or you just added to your application without being sure whether that one developer somewhere just built it. Do you know probably it's someone that wants to be mining crypto on your servers that built that image? No, you don't. But with container scanning, you can be able to check and test. Now, if you are new to software development, all these stages that I've mentioned here are the stages your software development passes through. You write your code. you need to test your code. Apart from the test you write, you need to test it against certain things to make sure that if you're using a language like, let's say, PHP, the quality assurance, is your code written well? Are you following certain PSR standard? After you've done that, the way your application behaves dynamically has to be tested. Even down to when your container or whatever package you are using is running in production, are you sure of how it's running in production and if it is secure? Now, this brings us to the concept called zero trust. Zero trust is where, you trust your employees, you trust your servers, you trust how things work on your systems. But as an organization, as a team, you want to guarantee that things don't go wrong. For example, there was a time at work, using Google Docs, I created a document. There's a way you can share, and you share for everybody on the public internet. The moment I shared it and I sent it to someone, I received a Slack message immediately. You shared a document out. Did you mean to share it for the public internet? You need to confirm and be sure that you are not exposing any company secrets in the document. If possible, change the permissions to make sure only the people you want to give it to have access to it. The same thing with our networks. There are some corporations that your office laptop, you cannot use it anywhere else except within the company. There are sometimes you have to connect to a VPN to work. There are some scenarios, there are some things you will even do on your system that it will lock you out. There are some networks you will work on. The moment it notices, it's called context-aware security. As soon as it notices some funny behavior, it will lock you out or ask you to relog in. That's what we call zero trust. You don't trust anyone just because they are an employee, because people can be used. The same thing with your software development. Now, we now have what we call, even developers building applications on their system now. Company give you a laptop. They still don't trust that laptop. We now have what we call remote development environments. You will have been hearing about code spaces, GitHub code spaces. We have Gitpod. We have even VS Code. We have VSCode.dev now, where within the browser you can write your code. So companies are now using remote development environment to guarantee that their developers are building those applications within a boxed environment, where they are sure that their developers will not compromise their source code. You now hear a lot of situations where company source codes have been exposed. So zero trust ensures that everything about the organization is secure, and at any point in time, if there's any red flag somewhere, it's immediately mitigated. Now, one of the things that happen in an organization is, in your CI pipeline, some of the things you do is to scan anytime your developers are pushing code. You run CI, do a series of tests, depending on your organization, a ton of tests. Some even do what we call secret detection. How many of us, there's no shame here, nobody will report it to your boss. How many of us have mistakenly put push.env to GitHub? .env, yes. I always say it's normal to make mistake. It's only a problem when your mistake gets to production. Now, when you push your code, your CI pipeline should be able to do what we call secret detection. It should check, did you push any AWS key? Did you push any API key? There was a time some researchers did a study. They went to GitHub and they scanned job logs, pipelines, people's pipeline job logs, and discovered that a ton of people were exposing their passwords. So hackers don't even need to do any serious wahala. Just go through people's job logs and pick out their API keys, their passwords, and so on. So a lot of CI pipelines now use security features called secret detection, and even remediation, where as soon as it detects a certain type of key, like AWS secret key, it will automatically go to AWS and rotate the keys, change it. So that even if it has been compromised, it will automatically be fixed immediately. Now, but all these things, you as a developer, you are running your CI. Your team is running their own. You discover a problem. Let's say you work in a very big organization. You discover a problem. How can we make sure as a company or as a team that team B doesn't experience the same thing? How do we ensure that in a large organization, a mobile department discovered a bug? For example, I think like a few weeks ago, there was a new CVE, like a bug that was released about OpenSSL. You as a developer, if you don't even know what to be OpenSSL, you don't know. But you just download a package that happened to have that CVE. Your security team should be able to prevent those things, or your engineering manager, or you as a DevOps professional, should be able to prevent that issue from happening, even if your developers don't know. That's where we have things like vulnerability management. You, as a DevOps engineer, should be able to manage every vulnerability that's happening within your project. Oh, someone exposed a key. There's a CVE somewhere. Someone did something wrong somewhere. You should have an overview of the vulnerabilities happening. So you can set up policies like, oh, if a secret has been exposed, immediately let's add security to the PR. They must approve the PR before it goes. If probably someone, for example, like Terraform, we noticed someone created a Terraform plan. And it be like, say, this amount where the thing go spin up, the servers where it go spin up, will cost us tens of thousands of naira. Let's add accounting to it to be able to show whether we can afford it. Let's even add infrastructure to ask the guy, do you really need this server that you are spinning up? Those are the kind of vulnerabilities that you as an individual or as a team or as a company should be able to have an idea. What are the vulnerabilities being discovered within your organization? Now, let's see, for example, what we call centralized view and mitigation. Here we have, you as an individual, you are building your code. You are discovering vulnerabilities. You are discovering issues. You can fix them, but you have fixed them. Your team, are they aware? Do they know the vulnerabilities you encountered? How do you know or understand vulnerabilities that someone else has encountered? Then at the departmental level, the same thing. Down to the organization. There are companies that have dedicated security teams that oversee all these issues around security that's happening within the organization, including they setting up policies. For example, you can say, oh, if I discover a change, a vulnerability that relates to NPM, let's pull in engineering manager for front end automatically to the PR. It might be that it's a back-end engineer that pushed the code or wrote the configuration and pushed. But he's not a front-end engineer. But he has made a change to something that relates to front-end. Let's automatically add someone from front-end team to make sure they review that PR before it goes. If secret has been exposed a number of times, let's introduce some professional development. Probably our team are not aware of something or don't have the knowledge for something. That way you can discover that my team is exposing secrets a lot. Let me get someone that will train them or get a training for them so they don't repeat it again. That is where centralized view and mitigation comes in when it comes to managing the security of your platform. Now, but all this, you'll be doing it within your own organization. Can someone else trust you? If you want to do, let's say you're a fintech, and you want to do PCI DSS certification, can they just trust you? Our server is secure and they will just trust you. Can CBN trust you? Or you are creating software, you are publishing software out there, and CBN wants to use your software. How do they know that your systems are secure? How do they know that, yeah, your system might be secure, but your suppliers, how do you know that they are secure? That is where a framework like the SLSA framework, supply chain levels for software architects, it was created by a team that includes Google and a couple of other folks to define, it's not a tool, it's a framework for how you can, as an organization, as an open source team, as a team in your company, you can ensure that the software you are producing is dependable. People can depend on it. And how can they do that? They can reproduce the same thing that you did For example, if you want to download, let's say, sometimes you want to download a software, they will now add a hash in the software page that once you download it, please hash it again and compare your hash with our own. If it is not the same thing, please no use them. But here, they are not just saying you should compare the hash. You should be able to recreate the same binary by we telling you this is how we built it. Then you built it yourself. If you generate the same thing, fine. But if you don't generate the same thing, something is wrong somewhere. Now, so there are different levels of the SLSA framework. We have level 1, which is like the easiest lift that you can adopt, up to level 4. Level 1 is still a work in progress, but level 1 and level 2 are what is available now, and everyone can adopt it within an organization. Let me quickly go through them. I think I have like 10 minutes. Level 1 of SLSA says all your softwares must be built automatically. You don't build on your system, or you don't involve a manual process. It should be done automatically. Probably you are using a CI platform, maybe like Jenkins, or you are using GitHub Action, or you are using GitLab CI. Use GitLab. I'm advertising. GitLab CI, or whichever platform, but it should be automated. Then you should generate what we call a provenance. A provenance is like a documentation of this is this software. This is how it was built. These are the dependencies that were used to build it. This is the environment that was used to build it. And these are the configuration that was used to build it. It's a configuration file. So that you, when you receive it, you want to consume the software, and you receive it. Okay, you can check, how did they build the software? What does the software contain? And you can even attempt to rebuild it and generate the same thing. That means you have confidence in the software you are using, which solve that issue of, do you trust the software that you are using? Now, and other things are being able to identify who actually pushed a code. How many times have you seen where there will be a controversy online that someone pushed so code to GitHub, you say he's not the one? Because it's very easy if you're using Git to go to Git config and put any name, any email address there. But platforms, your CI or your code platform should have a means to be able to make sure that you are the one pushing. There are what we call push rules. Push rules can include if certain conditions are not met, you cannot push to the GitHub or GitLab. If your code, your commit is not signed in a particular way that it recognizes using GPG, it should reject it. And a host of other rules that can be implemented. You can even put your own custom rules to say if the person doesn't even explain what they did and add the Jira ID or the Trello or whatever ID into it, reject the push. All those can be implemented to ensure that everything coming to your source system is secure. Now, level 2 involves you using, it's an extra level where you, as an organization, we should only trust your code if it is using a hosted, kept on a hosted server, like GitHub, GitLab. Because GitHub has been vetted. Everybody knows GitHub. They've passed through a lot of security review. So people trust them. But if it is on one server in the corner of your office, how are we sure your engineers don't just go and plug Flash and remove on the server? We are not sure. But if it is hosted, we trust it. Your build system too should be hosted. You are using Circle CI. You are using a hosted Jenkins software with a company that has been vetted, that has been trusted. They've gone through a lot of security reviews to make sure that their systems are secure. Not a server running on your system that's you've never updated it since Ubuntu 9.4 with a lot of vulnerabilities. And provenance is what I explained earlier to show that the software that I'm downloading has not been tampered with. The dependency I'm downloading has not been tampered with. Now, level and 2 are fully ready for anyone to adopt. But someone will be asking, where is this thing useful? It is useful in scenarios where you use, for example, if you use Kubernetes, and you want to pull in Kubernetes libraries like you're using kubeadm, you want to install kubeadm, you want to install the latest version of Kubernetes. Are you sure that version of Kubernetes that you are pulling is the right one? Someone has not done man-in-the-middle attack in your network to give you the wrong Kubernetes, like bypass the Git repo you are pulling and give you the wrong one. When you check the provenance, you generate the same thing. You see the result, compare it to what you actually downloaded, you'll be sure that, okay, it's the right one. Or an NPM package, you build the same thing again using the provenance. Probably when the slide comes back, I will show you an example of a provenance. You look at the provenance and see, okay, this NPM package I'm using is secure. So that anytime you are using the dependency of any supplier or any software from anywhere, your pipeline can be sure that it is the right one, it is the correct one, and there are no security vulnerabilities. Because now, at any point in time, hackers are no longer targeting you. They are targeting your suppliers. At least if we cannot get to you, we'll go through your suppliers. And who are your suppliers? Docker Hub, NPM registry, Terraform registry, Ansible, Galaxy, all of them. Someone can take over a project and push new binaries, or I think there was an open source project that a Chinese company took over, and people started noticing some tracking codes inside. There has been scenarios where even companies now can host their own Docker registry instead of using Docker Hub. They can have what we call dependency firewall. As a developer, you just want to push Docker pull COI. The CI will check, no, you cannot pull Docker pull. Use the company own. There's what we call dependency proxy. You want to pull an image or you want to pull from NPM or packages. The company instead will serve you the official versions that the company supports. They can even set rules that if you want to pull an NPM packages, we only support packages from certain publishers, certain approved and trusted publishers. Now, for example, on level 3 of SLSA involves that you, for example, like GitLab or GitHub, has gone through a lot of vetting process. Your Kubernetes software has gone through a lot of vetting process to be sure that their systems are secure. It's not just enough for you to just trust a service provider. You need to be confident. If you go to a fintech now and you ask them, do you have PCI DSS? You will not be like, we're in the process. You will not trust them because you don't have that confidence that their systems are secure. You don't have that confidence that their developers don't just have access to anything on the system, that they can just, I've seen a fintech where the developer went and shared the source code with Yahoo boys. They just finessed the company. Hundreds of millions of naira just gone. That is where supply chain. He did not commit a crime now, but although technically he passed on the code, and the people who can use it well used it. For level 4 involves more complicated review processes. You can look up salsa.dev to understand this better. This is an example of what a provenance structure would look like. The environments, the configuration source, the parameters, the code itself, how it will be built, and what it will be generated. Here is an example of a provenance. You will see here, this is an example of one generated by GitLab CI. It's detailing, this is what I built, this is how I built it, this is the environment, this is the parameters used, this is everything. So that you as a developer can now see, okay, this is how the software was built. I can replicate the same thing. As an organization, as a team, prioritize your supply chain security, because at the end of the day, even if no be you tifam, but because you are negligent, somebody can't tifam, now you tifam. Thank you very much.